The small shop owner has bought in the Santa or in any Raitu Bazaar.
एक ही जगह पे मिलके those type of plastics are known as thermosetting plastics. Comparison, there are 3 types:
up, down, right, left.
I am not inferior to anyone.
Dear Tswreis, you are top on the Everest. Congratulations.
I want to be a leader.
Hi Sparrows, how are you? And this is a Gangapus of 10th standard from Sirputi, Komramim district. Friends, today I have interesting topics to teach you. Do you want to learn them? Yes, I think you all are eagerly waiting to learn them. So let's move on to the screen. Friends, here we are going to learn about electric current, magnetic field, magnetic flux and electromagnetic induction. So let's learn about electric current. Electric current. Friends, in our daily life, we see different types of electric devices such as fan, bulb, television, etc. What is meant by electric device? Yes, a device which works through electric current is called electric device. Friends, here we used a word electric current. What is meant by electric current? Yes, the ordered motion of electrons or the amount of charge crossing through any cross section of the conductor in 1 second is called electric current. It is denoted by capital I. Electric current is denoted by capital I. The SI unit of electric current is ampere. The SI unit of electric current is ampere. If the electric current is equal to electric charge by time taken, it means capital I is equal to capital Q by small t. Friends, this is about electric current, and the next one is magnetic field. Friends, by Oersted experiment, we know that a magnetic field will be produced when the current passes through a wire. Let's prove this by doing a small experiment. Friends, to do this experiment, the required materials are a battery and a magnetic compass and a magnetic bar. And now take the compass and take a bar magnet and keep it near the compass and observe. Yes, the needle in the compass will deflect. Friends, now take away the bar magnet from the compass and observe. Yes, the needle in the compass will comes back. And now take the circuit of the battery and keep it near the compass and observe what happened, friends. Yes, the needle of the compass will deflect. Friends, here I have doubt. In first experiment, by using the bar magnet, the needle in the compass is deflecting, but here without using the bar magnet, the needle in the compass is deflecting. Friends, why this happens? Yes, when the current passes through the wire, the magnetic field will be produced. Because of that magnetic field, the needle in the compass will deflect, and this is about magnetic field. And the next one is magnetic flux. The number of lines passing through a plane of area is perpendicular to the area of magnetic field is magnetic flux. It is denoted by pi, and the SI unit of magnetic flux is Weber. The SI unit of magnetic flux is Weber. And the next one, electromagnetic induction. Electromagnetic induction. In 1831, Joseph Henry discovered magnetic induction. Michael Faraday's ideas about conservation of energy led him to believe that since an electric current could cause a magnetic field and a magnetic field should be to produce an electric current, he demonstrated this principle of induction in 1831. In 1831. So, electromagnetic induction explains about the amount of charge, the production of electricity due to the relative motion between a coil and a magnetic flux is called electromagnetic induction. This electromagnetic induction was introduced by Faraday, and he proposed a law on this electromagnetic induction, that is Faraday's law of electromagnetic induction. So, today my topic is also Faraday's law of electromagnetic induction and it uses in our daily life. So, let us learn the history of Faraday. He was born to a poor family in Nevington, England. He was diligent and intelligent. He became an errand boy for a bookbinding shop and he read every book that he bound. He became interested in the concept of force or specifically force. Because of his early reading and experiments with the idea of force, he was able to make the Faraday's law of induction. So, let us learn the Faraday's law. Friends, the Faraday's law explains about the changing magnetic flux produces an EMF or changing B field produces E field. The rate of change of magnetic flux is required. The Faraday's law in mathematical form we can write this as epsilon is equal to minus delta pi by delta t. To simple experiments demonstrate that a current can be produced by changing magnetic field. First, consider a loop of wire connected to a galvanometer as shown. Friends, here the loop of wire is connected to the galvanometer. If the magnet is moved toward the loop, the galvanometer needle will deflect in one direction. If the magnet is moved away from the loop, the galvanometer needle will deflect in opposite direction. If the magnet is held stationary relative to the loop, no galvanometer needle deflection is observed. If the magnet is held stationary and the coil is moved toward or away from the magnet, the galvanometer needle will also deflect. From the observation, you can conclude that a current is set up in the circuit as long as there is relative motion between the magnet and the coil. This current is set up in the circuit even though there are no batteries in the circuit. The current is said to be an induced current which is produced by an induced EMF. So, let us learn the Faraday's law. Almost 2200 years ago, around 1831, Faraday looked for evidence that a magnetic field would induce an electric current with these apertures. Here the apertures are magnetic bar and a coil and the galvanometer. He found no evidence when the magnet was stationary, but he did see a deflection in the galvanometer when the magnet was moved away or towards the coil. The importance of conclusion are, with the help of his experiment, Faraday drew 4 important conclusions which provided the basis of his law. The galvanometer showed deflection whenever there was relative motion between the magnet and the coil. The deflection was more when the relative motion was faster and the less when the relative motion was slower. And the direction of the deflection changed if the polarity of magnet was changed. The deflection in the galvanometer changes with the change in the number of turns of the coil, more the number of turns greater the deflection. Let us learn the applications of Faraday law in our daily life. The first application is ground fault interrupter. Ground fault interrupter is a safety device that protects users of electrical appliances against electric shock by making use of Faraday's law. Wire 1 leads from the wall out to be appliance to be protected. Wire 2 leads from the appliance back to the wall outlet. An iron ring surrounds the 2 wires and The sensing coil is wrapped around a part of the ring because the currents in the wire are in opposite direction. The net magnet flux through the sensing coil due to the current is 0. If the returned current is Y2 changes, the net magnetic flux through the sensing coil is no longer 0. This can happen if the appliance becomes wet, enabling the current to leak to the ground. Because the household current is alternating current, the direction keeps reversing. The magnetic flux through the sensing coil changes with time, inducing an EMF in the coil. The induced EMF is used to trigger a circuit breaker which stops the current before it able to reach a harmful level. And the next use is electric guitar. The coil is called a pickup coil and is placed near the vibrating guitar string, which is made up of metal that can be magnetized. A permanent magnet inside the coil temporarily magnetizes the portion of the string nearest the coil. When the string vibrates at some frequency, its magnetized sections produces a changing magnetic flux through the coil. The changing flux induces an EMF in the pickup coil that is fed to an amplifier. The output of the amplifier is sent to the speakers which produce the sound we hear. Faraday's law gives a rise to countless technological applications. The law has far-reaching consequences that have revolutionized the living of mankind after its discovery. Faraday's discovery of electromagnetic induction has numerous industrial, technological, medical and other applications. Some of them are briefed as follow. And the third use is electric generator. Friends, look at here, and this is the electric generator. Here the light, when we rotate it, the light blows. And let's make a small experiment, that electric motor, a simple electric motor. Here now to do this experiment, the required materials are a copper wire, a battery and a two safety pins. And now take a magnet and keep it near the copper wire and observe what happened, friends. Yes, when we keep near the copper wire, this copper wire will rotate. So this is called a simple electrical motor. See here, it is rotating, isn't it, friends? Yes. Now let's see in the screen. A generator transforms mechanical energy into electrical energy. This is an AC generator. The axle is rotated by an external force such as falling water or stream. The brushes are in the constant electrical contact with the slip rings. So this is the diagram of the electric generator. When we rotate the electric current, when the electric current is vertical, the electric current is 0. And the fourth use is induction stove. Friends, the pan of the stove is heated by eddy currents produced by induction. So this is the electric induction stove. And an AC current in the coil in the stove top produces a changing magnetic field at the bottom of the metal pan. The changing magnetic field gives rise to current into the bottom of the pan. Because the pan has resistance, the current heats the pan. If the coil in the stove has low resistance, it does not get hot, but the pan does. An AC induction stove. In induction cooking container, size, shape and position is very important to achieve maximum output. Only ferromagnetic materials like enable steel cast iron and stainless steel designed for induction can be used for induction cooking. And the fifth use is transformer. This is a transformer. A transformer is basically two coils of wire wrapped around each other or wrapped around the iron core. A transformer is a device for increasing or decreasing an AC voltage. A transformer is basically two coils of wire wrapped around each other, and this is the magnetic playback head of the tape. So the sixth use is, let's learn the tape record. The tape recorder that we use to listen songs or record voices or works on the principle of electromagnetic induction. It consists a small piece of plastic tape which coated with iron oxide. When the tape moves fast as a small coil, the magnetic field produced by the tape changes and the current generates in the coil. So we can listen this song or a record voice in the tape. So tiny coil responds to change in flux as magnetic demons go by. And the fourth use is credit card reader. A must swipe card generates changing flux, faster swipe, bigger signal. And the friends, when we go to the railway station or airport, the policemen are made to us walk through a big upright coil which produces a small AC current. When we carry a significant quantities like iron, the magnetic field which produced by the large coil changes and the current generates in the coil which triggers an alarm. Friends, so I thanks for the giving this wonderful opportunity to me. I thanks for secretary and my guide teacher K. Naveen Kumar sir. Thank you one and all.